Hello everyone, in this video we'll go over finding all extrema, so we're going to find local min and local max. So in order to do that we're essentially going to use the first derivative test. So we're going to find f prime. So let me actually delete this first. And now we just have to differentiate f of x. So f prime of x will be 6x squared. And that'll become 66x plus 144. Alright, so mind you that local extrema occurs when our derivative is equal to 0. So we'll set this equal to 0, and then we'll find all solutions. Now this is a quadratic, so we can just factor. We can plot a 6 of x squared. That should be a minus. So x squared minus 11x plus 24. And we can further factor that as x minus 8, x minus 3. Alright, so we can clearly see that this is equal to 0 when x equals 8 and x equals 3. So these are our critical points. Now we just have to determine whether it's a minimum or a maximum or even a saddle point. So in order to do that, we're going to start the first derivative test. So we know f prime of x is 6 times x minus 8, x minus 3. So I'll just set up a goalpost. Remember, x equals 3, x equals 8. So here we have 3, here we have 8. And what I'm going to do is that I'm just going to test values to the left of 3, to the right of 3, and to the left of 8, and to the right of 8. See the general trend of the curve. So I'll just pick easy points, like here I'll pick 2. So f prime of 2, 6, 2 minus 8, 2 minus 3. Now I don't actually care about the function value. All I care about is whether it's positive or negative. And that's essentially what the first derivative test is. So 6 times 2 minus 8, that's negative. 2 minus 3 will be negative. So negative times negative gives you positive. So f prime of 2 will be positive. So here we have positive values to the left of 3. And so we have downward slopes. Alright, so let's test something to the right of 3, like 4. Again, something easy. And let me get rid of this. So now we have to plug in 4. See what we get. So we have 4 minus 8 in this quantity and 4 minus 3. Alright, so again, don't care about the function value. 4 minus 8 is negative. 4 minus 3 is positive. So we have a positive 6 here. So positive times negative is negative. So we have a negative value here. Oh, I made a mistake here. This should be going upwards. So that's positive slopes here, and these are negative slopes. And now we just have to focus on 8. Now notice we already tested to the left of 8 by picking 4. So let's just test to the right. Let's pick 9. And we'll try it again. 6, 9 minus 8, 9 minus 3. It's positive, positive, and positive, which equals positive. So we have positive values to the right of 8, or positive slopes. Alright, so we can see the general trend here. We have, from the left of 3, we have positive slopes. And then to the right we have a negative slope. So essentially we have this general shape. So you can clearly tell that at x equals 3 we have a maximum. And then if you look around 8, we have, again, negative slopes. This whole thing is negative. And to make this a little more clear, draw a negative there. To the left of 8 we have down, and to the right we have up. So we have a max at x equals 8. Or I'm sorry, we have a minimum at x equals 8. And that's it. We found all relative extrema. We have a max at x equals 3. And a min at x equals 8. And that's about it.